David here with another question from topic 2.2. This is from the question bank and it's all about equilibrium. In this question, we have a ball that's attached to a string and is made to rotate with a constant speed along a horizontal circle with a given radius. The string is attached to the ceiling and makes an angle of 30 degrees with the vertical. So the ball here travels in a circle like that, and it's attached to the ceiling here. The question asks us to, on the diagram above, draw and label arrows to represent the forces on the ball in the position shown. So that's right here. Okay, so what are the forces on the ball? Well, if it's hanging from the ceiling, we can pretty safely assume that we need to consider the acceleration due to gravity, we need to consider weight. So let's add an arrow for the weight. Well, but then what? The ball is traveling in a circle, so you may be tempted to say that there's some sort of circular force. But actually there isn't. What is touching the ball? What is pushing the ball? What is pulling the ball? It's not the circle. Gravity pulls the ball, and pen please, thank you. Gravity pulls the ball, and the string pulls the ball. Now, the string, being a string and not rigid, is not capable of pulling in any direction other than the length of the string. You can't twist the string to twist the ball. You can only pull on the string. So we call this the tension, and it's along the length of the string. So then we have to think, well, hang on, how does the ball go in a circle? Well, it turns out that the tension and the weight act together. The tension has a vertical component to it, which balances out the weight. They're equal and opposite, meaning that the two vertical forces cancel, and there's no vertical acceleration. The ball doesn't move up or down. But that leaves the horizontal component of the tension unbalanced, and it forms what we call a centripetal force. But these two vertical and horizontal components of the tension, they're not forces in and of themselves, they're components of the tension. So in our diagram, we won't include them. That's our diagram with labels to represent the forces on the ball. There's only two, the force from the string and the force from gravity. It's very important that I label them because the question does say, label the arrows. If I leave the labels off, I probably won't get full credit. So maybe T should really be tension. Just to be clear and make sure that I get that point. And W should be weight. Just to make sure I get that mark.